Hello, this is Mr. Henry, and welcome to lesson 6.1. We are starting chapter 6, and this is all about these things called functions. Our essential question says, how do I determine if a given relation is a function? So we're going to learn about relations and functions and all that kind of stuff in this lesson here today. Did you know that a relation is just kind of a relationship between sets of values? So in math, a relation is between usually the x value and the y value. And the set of x values, a lot of times we call the domain, and the set of the y values we call the range. And we'll see there's other names, like x values are sometimes called the input variables, and the y values are called the output variables. So these kind of the names x, input, domain are kind of interchangeable when you're talking about functions. So it's kind of a weird thing. It's just a kind of new vocabulary for the same words. Okay. So a relation, just as the last page said, a relation is just usually it's a set of ordered pairs. But these ordered pairs, there's a relationship between the x variable and the y variable. Okay, a lot of times that relation is in the form of an equation. So if you think of an equation, so for example, y equals 2x plus 8. Well, if I plug in the point 3 in for my x variable, so that's my input, that's my part of my domain. If I'm plugging him in and I do the math, 2 times 3 is 6, 6 plus 8 is 14. So the output variable is 14. So when I plugged this one in, I got this one out of the equation. Okay? And so a lot of times we get these just a set of points. And that set of points can be shown using a table, lists, graphs. I could graph that point on a coordinate grid. Okay? So input. Well, input is usually the x-coordinate of a relation. And again, we call that guy, sometimes we call him the domain of the function. The domain is the set of all the numbers that you can plug into a function. And then the output variable is just the opposite. It's the y-coordinate of the relation, and we call that the range. And the range is just the set of all of the possible y values of a function. So let's see a little bit about figuring out if something is or is not a function. So example 1 here says, we're going to make a mapping diagram for each relation. Determine if each relation represents a function. So first off, this is a mapping diagram. So I don't have to make it here. So basically, do you see how the number -2, if I plug it into the function, it spits out an answer of -1. 5 spits out the answer of 0. 7 spits out the answer of -1. Okay? So I don't have to make a mapping diagram. There's already one made for me there. So what I need to do is I need to determine if this is a function or not. And I will tell you right now, the answer for this first one is yes, it's a function. Now, how do I know that? I know that because for something to be a function, and I'm thinking there's probably a vocabulary I missed down here. See? For something to be a function, each input has exactly one output. That is incredibly important. That is like the definition of what a function is. So in this lesson, if our job is to figure out if these things we're looking at are functions, that's the rule that I'm going to go to every single time. So for every input I have, is there exactly one output? Okay. And vertical line test, well, we can get him done now. We're not going to use him for a little bit. So the vertical line test is only used when you have a graph. of a function, or a relation, I should say. And we can use this vertical line test to determine if the graph we're looking at is actually a function or not. So back over here, now that we have the definition of what a function is, does each input have exactly one output? Well, let's look here. This -2. When I plug him into the function, I get an answer of -1. Do I get something else? Do I have two answers for one problem? No. When I plugged in 5, I got 0. Did I get two answers for one number? No. When I plugged in 7, I got -1. Did I get two answers for plugging in one number? No. And that's what we want. How many math problems do you know of if you plug in, think of an equation, like y equals 5x plus 2. Just some equation I make up. Okay. How many math problems do you know of if you plug in one number here for x, say 3 for example, do you get two different answers for y? And you may not be able to think of many off the top of your head, if any at all. If you can think of one, then there's a good chance that if you plug in one value for x and you get two values for y, the thing you're looking at is not a function. Okay? This one here is a function, and that's why. Because each input only had one output. Each time I plugged in one number, I got one answer. Okay, letter B. So now this one is not a mapping diagram, so I'm just going to make one quick. Whoomp, whoomp. We got, I'll call this guy the domain. I'll call this guy the range, which is the same thing as input and output. Input is domain, output is range. I'm trying to use the words interchangeably so you kind of make the connection. It's the same thing. Now for the domain, I'm just going to write down my numbers here. So the order doesn't usually matter. Most people put them in order from least to greatest. So if I do like -5, -3, 0, 5, 6. My range, I'm just going to list, again, these numbers here, just kind of in order from least to greatest, which it looks like it already is. So -3, -2, -1, 5, 7. And now the mapping part is I just draw from the input to the output. So 5 goes to -3. I'm sorry, -5 goes to -3. 0 goes to -2. +5 goes to -1. 6 goes to +5. -3 goes to +7. So there's my mapping diagram. Now, is this thing a function? You got to ask yourself, every time I plugged in one number, did I only get one answer? And the answer is yes. Yes, this is a function because each number I plugged in only gave me one answer. Yes, that is a function. Okay, letter C. Now, this, for some folks, is a little confusing to look at. Well, that's why we have these mapping diagrams. Now, remember how I said they don't have to be in order? So if I put in like I'll just put input now. Output. So the x variable is your input. So I'm going to put in the first x variable. The y variable is the output. So this one was taken care of. 4, 3, boom. 2, 6, boom. 4, 2, but I already have a 4. I'm not going to put another of the same number. So I already have 4, 2, boom. So now, when I map it out, 1 goes to 5, 4 goes to 3, 2 goes to 6, 4 also goes to -2. So, remember those past couple problems when we were saying like if it is or is not a function? This guy right here, not a function. And I'm going to see if you can figure out why. Look at it quick. Come up with an answer in your head. Why is it not a function? If you said because of this number 4 right here, because when you plugged in the number 4, you got 2 different answers. That is not a function. For it to be a function, each input has exactly one output. So this is not a function because the input of 4 has 2 different answers, not a function. Okay? Letter D. Same deal. Make myself a mapping diagram. Boom. Boom. Looks like I'm going to use the numbers 5, 6, 7, 8. 5, 6, 7, 8. And 1 through 5. 1, 2, 3, 4, 5. I'm going to change color for mapping. 5 goes to 1. 6 goes to 2. 5 goes to 1. 6 goes to 2. 7 goes to 3. Boom. 5 goes to 4. Here's 5 going down here to 4. 8 goes to 5. Okay, so mapping diagram complete. Input, output. There we go. Now it looks better. So my mapping diagram is complete. Now, ask yourself, is it a function? Yes or no, and why? Hopefully you said the answer is no. This is not a function. And hopefully that wasn't just a flat out guess. And you said because 5 here has 2 different outputs. That is not allowed. It's not a function. Okay, let's keep this gravy train rolling. Here's letters E and F. So we've done, I don't know what, 4 already together. See if you can make this mapping diagram for letter E on your own. So pause the video, do your mapping diagram for letter E, see if you can figure out if it's a function or not. For letter F, well, it's already a mapping diagram made for you, so you really don't have to make it, but still determine if it's a function or not. Okay, so pause the video, do these 2 problems on your own. When you're ready, continue, hit play, and we'll go through them together. Okie dokie. So we've got circle dude. 3 in X, 6 in Y. -2 in X, -1 in Y. -1 in X, 4 in Y, 6 in X, 4 in Y. I don't need to put another 4 because I already have one. Okay. This is my input, my output. Sometimes also called the domain and the range. These guys come from the X values. These guys come from the Y values. Those 3 names all kind of go together when you're talking about functions. Now, I map them out. So 3 goes to 6. Boom. -2 to -1. Love it. -1 to 4. 6 to 4. Is this a function? Now, you might be tempted to say no because you're looking at this guy over here and go, well, he's got 2 guys that have the same answer. That's okay. That's not what the rule for function says. The rule for function says each of these numbers over here can only have one output. So this guy only has 1. He only has 1. He only has 1. And 6 only has 1. Even though these 2 have the same eventual answer at the end, that's okay. What's not okay is for one number to have 2 different answers. So yes, this is a function. Okay, letter F. The mapping diagram was already made for us. We did not have to make one. So now we just had to figure out, is this a function, yes or no? And hopefully you said no. Look at this dude. He has 1, 2, 3, 4 different answers. So when I plugged in this number one time, it gave me 4 different answers. That is a huge no. No, this is not a function. Okay? So hopefully now you can tell by looking at a set of points, a table, a mapping diagram, whether something is or is not a function. I understand functions are still a little weird, and you don't really have a good grasp of it. You could probably identify if something is or is not a function, but we don't know what a function really is yet. Don't worry, we're getting to that. This whole unit is all about functions, okay? Now, the second thing is from a graph. I've got two pictures here. I want to know, is this graph a function? So here's how we tell this. Remember that one vocab word we had up here down the bottom? It was hiding, called the vertical line test. Well, it says it's used to determine if a graph of a relation is a function. Let's see how that's used. So here, I'm going to take my line. I'm going to make him, why not green? I like green. It's my favorite color. So I drew a nice vertical line. And what I'm looking to see is, I'm going to take this vertical line, and for you, on your paper, you could use like your pencil, and you just take your pencil and you drag it across your graph, kind of like I'm doing here. And what you're looking to see is, at any point, at any one point, if you stop and you drop your pencil somewhere, is your pencil, or is my line, touching the graph, the relation, at more than one place at the same time? Like right here, it's touching at this point right here. If I swipe over, it's touching at that dot right there. Over here, it's touching at this point. And no, you don't count the arrowheads. You can't say, oh, right here it's touching there and there. No, the arrowhead doesn't count. Okay? So does this line touch my relation at more than one place at the same time? The answer is no. Which means this is a function. This passes the vertical line test. I'm even going to write that down here. Passes vertical line test. My handwriting is terrible tonight. All right, it is a function. It passes the vertical line test. Now, for an example of one that does not pass, this guy. So there will be times where there's places like here, like off to the left here, where my line doesn't touch the relation at all. Like there's just nothing here. That's okay. You can have a function and it still looks like that. What's not allowed is right there. Do you see how it's touching at two places at the same time? It's touching right here. Black was a bad color. It's touching right here and right here at the same time. And if I slide over, any place over, it's touching right here and right here at the same time. It is failing the vertical line test. This graph is not a function. It fails here. Boom, boom. So no, this one is not a function. Whoa. You know what? Let's try this another way. Since my handwriting is terrible tonight, not a function. Because it fails a vertical line test. Apparently I can't type either. Okay? So it's not a function. It fails the vertical line test. Because my vertical line touches the relation at more than one place at the same time. That is not allowed. Okay. Letter C. Now, letter C, you may not have the dots on your paper, so you might need to copy them in there. Just copy them exactly where they are on the screen here. Now, just letter C. Don't worry about letter D. He looks kind of weird. We're not going to talk about him just yet. But letter C. Is that a function? So draw your do your vertical line. Use your pencil if you need to, or just imagine a straight up and down line. Does a vertical line touch 2 points at the same time? Go ahead, pause the video, get your answer down. When you're ready to continue, hit play. We'll go through it together. All right, so here I go. Here's my vertical line. You can pass from the left or from the right. It really doesn't matter. You just got to check to see, does it touch any place at more than once at the same time? Nope. It's touching one dot there. No dots there. one dot there, no dot, no dot, no dot, one dot, no dot, no dot, one dot, none, 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 one. That's okay. Everywhere on there was okay. What would not be allowed is if I would have a second dot, say here. This would now fail right there. That would not be a function. But he's not here, so this is a function. All right, now I'm going to take my same vertical line, and I'm going to swipe over to letter D. So here we go. I've got one dot, that dot right there, okay. And he's touching a line, okay. He's touching a line, he's touching a line. What about right there? Let me ghost mode this line a little bit so you can, it's more transparent, so you can see the background. So right here, is that touching 2 points at the same time? The answer is no. This solid dot, that means the point is there. So this line is going through this point right here. But this hollow dot means there's no point there. When you learn about inequalities, you learn that there's these, when you're graphing an inequality, if it's like x is less than 5, we use a hollow dot. This hollow dot basically means you can be really, really close to that point, but there's nothing actually right at that point. This hollow dot, there is nothing right here. It's just showing this line gets from this point here to right close to this. So this point right here, this line is okay. This still represents a function right here. This is not two separate points. The line's not going through 2 points at the same time. It's only going through this one. This is not actually a point. That's why it's hollow. Now if we continue our line across, boom, 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 it's just going through one line right here. Right there. Now, does it fail right here? The answer is yes. It does fail right here because it's going through this dot here and this dot here. See how they're both solid? Solid filled in dots means there's actually a point there. So because it's going through both this guy here and this guy here at the same time, this is not a function. Not a function. It fails the vertical line test. Right here, right where I have my line right now, is where it fails the vertical line test because it's going through both of these dots at the same time. And it doesn't matter if it passes over here or everywhere else. As long as you find one point where it does not pass, it fails. It is not a function. Okay. Here are two graphs I would like you to try. So you can make a sketch of them. You don't have to put the lines exactly where you see them. You see letter E is linear. It has a negative slope. Just make a quick sketch. You see letter F has this like a sideways V shape or a less than symbol looking shape. Just make a quick sketch and then determine if they are functions or not. Pause the video. Do them on your own. When you're ready, continue, hit play, and we'll go through them together. Alright, so I'm getting my vertical line out here. There he is. So letter E, does it pass vertical line test? Yes. My line only touches this line at one place at a time. This is a function. So I'm going to put yes, function. Now if I take my line over to letter F here, my line is crossing at two places right now, right here and right here. That two places means this is not a function. And if I just keep going, it fails pretty much everywhere. Fails there and there. This guy here is not a function. Not a function. Okay. It fails the vertical line test. It passes the vertical line test. Now, before we go ahead, I wanted to show you something. Back here, back in these early examples when we were looking at these tables and stuff, if I would take these points here and I would graph them. Let me see, do I have a graph thingy here? Content, pictures, nice. Alright, get out of here. Alright, so I just threw up a little quick graph here, right? If I take these points, we said this guy was not a function. If I take 1, 5, 4, 1, 2, 3, 4, 1, 2, 3, 2, 6, 4, 2. That's these 4 points I just graphed right here. Do you see why, according to the graph, it would not be a function? And hopefully you're saying because it would fail the vertical line test. Yeah, it would. Right here. Let me make it a little transparent so you can actually see the dots again. So right there, it fails the vertical line test because these 2 points, 4, 3, and 4, 2, are vertical of each other. It fails the vertical line test right there. Okay? That's another reason why this is not a function. Now, if I try the same thing here with letter D, 5, 1, 6, 2, 7, 3, 5, 4, 8, 5. So that's these points. I just graphed them very quickly. And it fails right here. When I had my mapping diagram, not too terribly long ago, I had these here. I had 5 going to 1 and also a 4. I had this sort of thing going on. That is this. This one input had 2 different outputs. We said it was not a function here. One input, the input of 5 in the x-coordinate, had 2 different outputs. Not a function. Okay? So I'm trying to just make the connection between what we were doing here with our tables and this input-output diagram thing and our vertical line test. They really are the same thing. It's the same rule. It's checking for, does each x value have only one y value? Here, letter D, or letter B while I'm looking at it. If I pick an x value, a point on my x-axis, I pick this point right here. When x equals 2, I have 2 y values. I have the y value here, so I have an x value of 2, negative 2, but also I have 2 and we'll call that 2.2, whatever, or 2.3. Positive 2.3. I've got 2 different points. When x is equal to 2, I have 2 y values. That is not a function. Okay? Boom, boom, boom. Yeah. I think I said everything I wanted to say about that. So I think the next thing is just doing some problem solving. Same idea, though. So first one here says, Arnold recorded the number of minutes he typed and the number of words he typed in that amount of time. The inputs are the minutes Arnold typed. The outputs are the words he typed. Is the relation represented by his table a function? Okay, so we have a table. Just like we had tables back here, we have a table, and we want to know, is this thing a function? Well, what I'm looking for is these. The first variable is always your x variable. The second one's always the y. You can call this the input. This is the output. This would be the domain. This would be the range. Okay, so we got all of our possible labels in here. So we're all talking about the same thing. So, does each input have only one output? So what I'm looking for is if I look at this, 35, 25, 23, 46, 50. Notice I didn't really put the numbers in order. That's okay. And I'll make this one bigger just because numbers are bigger. 515, 323, 299, 489, 788. Now, if I start mapping, 35 minutes, 515 words. 25 to this guy, 23 to that guy, 46 to this guy, 50 to that guy. I have each input with exactly one output. I don't have any of these that have a second branch coming off. At 35 minutes, he only had 515 words typed. There is not a second number of words at the same time. So this is a function. If I were to graph this, which I'm not going to do, but if I were to graph this, all my points would be separate from each other. They would be kind of like that, I would imagine, shape. But they would all pass the vertical line test. Letter B, this is one for you to try. It says Lisa has the graph below. Which 2 points can be removed to make the graph below a function? And why did you choose the points you did? So I want you to pause the video and figure out which 2 points here you would remove. Give the ordered pair. Like I would remove the point at, play pretend, like 3, 2, whatever it is, okay? Which points would you remove and why? Go ahead and pause the video. Do it on your own. When you're ready to continue, hit play, and we'll go through it together. Okay, so hopefully you said you would remove one of these and one of those. There. That's a shortcut to the answer. Now, why did I say those things? Well, because right there at those 2 places, they fail the vertical line test. If I take my vertical line out, here he is. Ain't he beautiful? He fails. He's touching 2 points at the same time right here. Over here, 1 point, 1 point, 2 points. This is bad. So you need to remove one of these. Not both of them, just one of them. So if you say, I don't like him. Okay, so you'd say, I'd remove the point at 1, 2. That's his coordinates. Okay, we keep going, keep going, keep going, keep... Uh-oh. Right there, it's no good. It fails right here because it's touching 2 points at the same time, so you have to remove one of them. Pick one. I don't care which one. Pick one. So if I remove that one, that's the point -2, 1. So by removing those 2 points, now I would pass the vertical line test. So if I can, check this out. White him out, and remove my little, no. There, magic, right? So now it passes, it passes, it passes, it passes, it passes. So now this would be a function that passes the vertical line test. That's what you'd want to say in your answer. You'd want to say, I'd remove whichever points you picked. And I'll be honest, you didn't have to pick this point up here. You could have picked this guy down here. And you could have picked that one there, or it doesn't matter. As long as you picked one of the points that made it fail the vertical line test, you're good. And you picked them because it made the relation fail the vertical line test. Hey, and that's it. That was a fairly short lesson, only 33 minutes. Summary says, in your own words, describe how to tell if a relation is a function. So if you need to, go back through the notes. How did we tell if a relation is a function? What were we looking for? This has been lesson 6.1. Thank you for watching.